Let's start solving this absolute value inequality by first isolating the absolute value by subtracting that 5. So let's subtract that 5. This will give us the absolute value of 4x minus 20 less than or equal to 21 minus 5 is 16. Now, here's how I'm going to do this. I'm going to translate this statement into English. I'm going to write an English sentence that says what this says symbolically. Here's how it goes. It says the distance between, BTW for between the number 4x minus 20 and 0 on the number line All right, now what I've got so far is this right here. The distance between the number 4x minus 20 and 0 on the number line. That's this part right here. As soon as I see absolute value, I'm thinking distance. And whatever I see inside is going to be this number from 0, the distance between that number and 0. So it's like a template, what you've got here. It's always going to be the distance between the number, write down what you see inside, and 0 on the number line. So it's a template. The distance between the number, what you see inside, and 0 on the number line, and then is less than or equal to, so let's say that, is less than or equal to, and then we've got this number here, 16 units, because we're on the number line, so we're dealing in units. So all in all, this statement here symbolically translates to this in English. The left side is the distance between the number 4x minus 20 and 0 on the number line is less than or equal to, right there, 16 units. So let's draw a picture of what it means. Here's the number line, x, and here's 0. That's our start point right there. There's 0. So our question is that where could this number be? Where could that number 4x minus 20 be? Well, here's what we know. We're bounded. It's what? It's less than 16 units from 0. So we're bounded by 16. Now, if we're at 0 and we move off to the right, we're bounded here by, 1, 2, 3, 4, 5, up to 16 units. So we could put a point out here at 16. I'll draw a closed circle because of that equal sign. So that would be 16, and I know that that 4x minus 20, that could go anywhere in here, right? If we drop that 4x minus 20, if we take that 4x minus 20 and just pull it out and put it anywhere here, we are less than or equal to 16 units from 0. But now we could have moved to the right, to the left. So if I'm at 0 and I move to the left, if I go 16 units here, then I'm over here at this number negative 16. I'll put a closed circle here. And if we drop that 4x minus 20 anywhere in this region, then we're still less than 16 units away from 0. So we're saying now that that 4x minus 20 could be anywhere in here, right? That 4x minus 20, if I put it anywhere in here, it's less than 16 units away from 0. If I go to the right, in here I'm less than 16 units, less than or equal to, and if I go to the left, I'm less than or equal to 16 units. And now, if I just look at my picture, it's all right here. Just bring everything straight down. Bring it all straight down. So I'm going to bring this down. I'll bring the 4x minus 20 down. I'll bring this down. Here's what it looks like. Negative 16 is to the left, right? And I'm off to the left here. It's to the left of, then the 4x minus 20 comes up, right? That negative 16 is to the left of the 4x minus 20. Negative 16 is to the left of the 4x minus 20. And the 4x minus 20 is to the left of the positive 16, right? That 4x minus 20 is to the left of positive 16. So we've got that negative 16 is less than or equal to, is to the left of the 4x minus 20, which in turn is to the left of the 16. That 4x minus 20 less than or equal to 16. And now we can solve this. What we're going to do is try to isolate this x, right? We want to isolate the x. So let's add 20. So I'm going to add 20 to all three sides now. So like I'm doing this, plus 20, plus 20, plus 20. Now negative 16 plus 20 is 4. Less than or equal to 4x minus 20 plus 20 is just 4x. Less than or equal to 16 plus 20 is 36. And I'm going to divide by 4, right? I want that x isolated. So divide by 4. Divide by 4, by 4, by 4. If I divide all those by 4, I'm going to get 1 less than or equal to x less than or equal to 9. So here's our solution in inequality form. And if I change that to interval form, I know I've got left comma right. So the left is going to be here at the 1. The right is going to be at the 9. So I'm going to write this then as 1. Let's see if I can get it to write. 1 comma 9. Now, the 1 is included because of the equal sign, and so is the 9 because of the equal sign. So we're going to have square brackets around the 1 and the 9. And now we're going to claim that this is our solution. That's the proper form, right? Interval form. In problem number 9 here, we want to solve this inequality with absolute value. So the first thing we'll do is subtract the 2. That'll give us the absolute value of 3 minus x greater than, strictly greater than, 5 minus 2 is 3. And now I'm going to write the meaning of this symbolic sentence right here. It means this. The left side is the absolute value, and that's always the distance. So I'm going to say the distance between BTW, the number, whatever I see inside, 3 minus x in this case, the distance between the number 3 minus x and 0 on the number line. Right, now that's the left side. That's this. What this means here in English is this. The distance between the number, what I see inside, and 0 on the number line. So this part here is just what I fill in. The rest is a template. It's like a blank field. It always goes like this. The distance between the number, blank, and 0 on the number line. And the blank is just whatever you see inside. So we've got the left side. I've got this side right here. The distance between the number 3 minus x and 0 on the number line is greater than, right, there's our greater than sign, 3 units. Is greater than 3 units. Let's get the graph. So I'm going to draw this number line, label it x, and I'll mark our 0. And now, where could this 3 minus x be? This 3 minus x is greater than, it's more than 3 units away from 0. So if I'm at 0, and I go out 1, 2, 3 units, where is that 3 minus x? That 3 minus x, well, this has to be greater than, right? It has to be farther than 3 units away. So if we go out 1, 2, 3, now put an open circle because the 3 is not included, that this 3 minus x has to be out here, right? Does that make sense? Because then if I'm out here, that 3 minus x is more than 3 units away. So the 3 minus x could be out here. Now, if I'm at 0 and I go to the left, I'm going to be over here at the number negative 3. I'm going to put a closed circle here at negative 3. And where is that 3 minus x located? Well, that 3 minus x has to be greater than 3 units away. Now, if I mark it in here, I'm less than 3 units away. If I mark it right here, I'm exactly 3 units away. So I think we have to mark it over here, because if it's over here, it is now more than 3 units away. So let's mark it over here. That could be a location for it. So that 3 minus x could be in that interval right there. So now, from this graph here, we can get our inequality. So let's just write what we see. This 3 minus x is to the left of negative 3. So I'm going to write that just like this, that 3 minus x is to the left of negative 3. It could be there. Or this 3 minus x, right, this 3 minus x could be over here to the right of positive 3. Or that 3 minus x could be over here to the right of positive 3. So let's solve each one of these. Let's subtract 3. So we'll get negative 3 less than negative 6. Now, here's what I'm going to do. I'm going to divide or multiply by negative 1. Alert, we're multiplying or dividing by a negative sign, right, by a negative number, so it changes the direction of that inequality sign. So now we're going to get x is greater than negative 6 divided by negative 1 is 6. And on the right side over here, if we subtract 3, we're going to get negative x greater than 0. And then if I multiply both sides by negative 1 or divide by negative 1, I'll get x less than 0. So x could be greater than 6, or it could be less than 0. So let's see if we can write that in interval form now. Let's just check that. So x less than 0 means we're to the left of 0. So we're to the left of 0. So we're 0 and all the way out to the left. Or x is greater than 6, so we're at 6 and then all the way out. So here's our interval form. So let's claim now that this is our solution in interval form.